Hi, I'm Eric, the security guy. In security architecture, we often talk about defense in depth, but in practical terms, what does it really mean? The concept of defense in depth predates computers. It's originally a physical security concept, and as a result, there are many interpretations. As it pertains to cybersecurity, I define defense in depth as a security strategy that provides multiple, redundant defensive measures in case a security control fails or a vulnerability is exploited. Let's consider how a defense in depth strategy could be used to reduce the risk of a user's computer being infected by malware, including ransomware, since that's unfortunately a very frequent occurrence these days. Most endpoint malware infections originate in an email or sketchy software download. Email can contain an infected or hostile attachment, a link to a website that exploits a browser vulnerability, or a link to download infected software. A lot of malware is multi-stage. The first stage is as simple as possible to avoid detection. In some cases, its only job is to download the next stage and run it. So we're essentially dealing with two infection vectors, email and web downloads. Starting at the keyboard, we can educate people on the risks and ask them to never click on links in email, like I asked everyone last week. But we know that anyone can make a mistake, and unfortunately some people will click on almost anything. Next, we can install endpoint protection software. Perhaps we'll use one that comes with the operating system, such as Windows Defender. Or maybe we'll opt for a machine learning-based solution like Cylance or CrowdStrike. While some individuals and organizations stop there, the evidence suggests these two controls are just not enough. To further address the email vector, we can add additional controls, such as a warning banner on external emails to remind users of the risk. We can also block commonly exploited file types at the email server, and hopefully our email service includes some type of malware scanning. Next, there are affordable third-party email security providers such as Proofpoint. While it does add additional expense and administration overhead, Proofpoint provides more control over inbound email and can detect malicious content that many email providers miss. And my wife will tolerate it. So at this point, we have two different email security layers before the message even arrives in the user's inbox. We've trained the user, included warnings in external emails, and we hope that the endpoint protection software will stop malicious code from executing. Having done our best with email, we can turn our attention to web downloads. Some organizations use advanced firewalls, intrusion prevention, or unified threat management appliances that inspect ingoing and outgoing HTTP and HTTPS requests. While some products are capable of inspecting encrypted traffic, blocking can also be performed by comparing the destination to threat intelligence lists. For example, requests to known malicious servers or even previously unknown domains could be automatically blocked. Services such as Cisco Umbrella, formerly known as OpenDNS, and Sierra Canadian Shield can provide additional protection against malicious downloads and phishing sites at the DNS layer. Finally, we should consider backups and disaster recovery as part of a defense in depth strategy. If all else fails, a good backup system will facilitate wiping the drive and reinstalling the operating system with minimal, if any, data loss. Defense in depth principles should also be applied to networks and web applications. Too many companies deploy a web application on a virtual machine, open the HTTPS port to the internet, and just hope that the application won't get hacked. Network devices such as application load balancers and web application firewalls can repel many types of attacks. The application itself can also be designed to be intrusion resistant, and in some cases, even the choice of programming languages can help. I'm not going to go into the nitty-gritty of secure web application design in this video, but if enough people express interest, I might record a longer video specifically on that topic. Thank you for watching. Please help me out by liking this video and subscribing to my channel. As always, if you have any questions or you'd like to suggest a topic for a future video, please leave a comment below. I'd love to hear from you. See you tomorrow.